Well, hey everybody, Mr. Reeves with you, and we are now looking at IXL, 8th grade, skill Z12, writing a linear function from a table. So, quick review, we've talked about linear functions or linear relationships. We had a proportional relationship, which was y equals k times x. So, in that relationship, if you wanted to know what y was, you were multiplying by a single value, okay? And then we had a non-proportional relationship, which we have just started talking about, and we said that for that, y was equal to mx plus b. In that case, we were still multiplying by something, but we were adding or subtracting. Okay, so when we are writing these linear functions, it's either going to be multiplied by something or it's going to be multiplied by something and added. Now, I just want to bring one more thing to your attention. If we have this one, if that value of m is 1, then it's simply going to be adding or sometimes subtracting. So, this is what I'm going to ask you to do when you're looking at these tables. Look and ask yourself, are we simply adding or subtracting something to x to get y? So this is what you need to ask yourself. How do I get y from x? Sometimes you're simply going to be adding or subtracting a number. Sometimes you're simply going to be multiplying a number. And sometimes you're going to be multiplying by a number and then adding or subtracting. That's when it gets the trickiest, okay? So some of these ones at the beginning are going to be a little easier, and as we go on, as usually is the case with IXL, it will get more challenging. So again, how do I get y from x? Can I just add or subtract? Can I just multiply, or do I need to do this combination of multiplying and then adding or subtracting? Okay, so if we take a look at this first table right here, from 0 to 15, what happened? They added 15, right? Did they do that same thing from 1 to 16? And you can see that the answer is yes. They simply added 15 every time. So what does that tell us? Y is equal to x plus 15. If you want to know what y is, simply add 15, and that is that one right there. All right, what about this one? Well, they've already set up the beginning. Y is equal to x minus something. Well, what are they doing? We are simply subtracting 1 every time, right? Minus 1, minus 1, minus 1. How do I get y from x? I simply subtract 1. All right, again, they're being nice to us. They're telling us we're simply going to multiply by something here. Well, what do you multiply by each time? It looks like we're multiplying by negative 13 each time, right? Negative 13 each time. Okay. Now again, if we look 4 to 35, well, that's 4 does not go into 35, so we're not multiplying. But we can add what? 31, add 31, add 31. Do you see how if you want to know what y is, you're simply adding 31, excuse me, each time. Here's another case where we're simply doing the same subtraction problem every time. We're simply subtracting 3. Okay, now if we take a look at here, if we go from negative 1 to negative 13, well, that's minus 14. That's not minus 14, so we're not subtracting. What about multiplying? Well, yeah, that's times negative 13, isn't it? Okay, so this is like that one we did before where we're multiplying by negative 13, but we're not adding anything, all right? There's nothing else being added. All right, another clue real quick. If you look right here, this is going to tell us our y-intercept. Remember, for every y-intercept, x is 0. So that is another clue right there. Our y-intercept was 0. We simply were multiplying by negative 13. All right, let's see here. 2 goes to 62. Well, that's just plus 61. Here's another case where we're simply adding. Now we're adding 61 at the end, which means we're multiplying by 1, right? When all you're doing you're adding or subtracting to get the answer, then that number right there will be a 1, right? 5 times 1 plus 61. 4 times 1, because when you multiply by 1, it doesn't change. Now, if you're going to, well, isn't that just the same as writing y equals x plus 61? It is. In fact, you could put 1 there and have it be marked correct, or you can simply not put 1 there, but that doesn't mean it's a 0. If you put a 0 there, it'll be wrong. All right, I'm going to go ahead and put a 1 there just to reinforce the idea. Times 1 plus 61. Oh, plus 60, my bad. Whoops. Times 1 plus 60. Okay. Back here, what are we doing? We're simply taking away 5. Times 1 minus 5. Let's see if I can get it right this time. There we go. All righty. Okay. Take a look at this one here. Is it simply plus the same thing? Well, that would be plus what? 19? That's definitely not plus 19. Are we multiplying? Well, that would be times 2. Well, that'd be what? Times 10 and a half, right? Times 10 and a half. Is that the case here? Well, let's take a look here and see if we can find the slope and the y-intercept. I think we have an interesting one here. Y equals mx plus b. Remember, if it's not just adding or subtracting and it's not a multiple, then it's going to be a combination of multiplying and adding or subtracting. Again, where m is the slope and our slope is our change in y over our change in x. And b is our y-intercept. And remember, that's when x is 0. That is our y-intercept right there. So if we take a look at the change in y over the change in x from 21 to 44, I do believe that's plus 23, right? If we do it again, it's plus 23, and that's plus 23. All right, so what is our slope? Our change in y over our change in x is 23. All right, now if I were to do that, if I did 2 times 23, what would I get? I would get 46, but I'm supposed to get what? Supposed to get 21. If I did 3 times 23, what would I get? I would get 69, but I'm supposed to get 44. So do you see how multiplying by that 23 doesn't give us the answer? We have to subtract something. We have to subtract something. If I did 4 times that 23, what do I get? I get 92, but I have to subtract something to get to 67. Well, that's something that we're subtracting right there. That's going to be our y-intercept, okay? Now, there's several different ways we can find that y-intercept. We can just do some, say, okay, well, what do I have to do to get from 46 to 21? Well, what's the difference between 46 and 21? Well, 6 minus 1 is 5. 4 minus 2. So wait, if I subtract 25, that will work, right? So I know that's one way to do it. Just subtract the two numbers and find the difference between them. All right, another way to do it, let's take this table and let's continue it. 5, 4, 3, 2, 1. We need it to go to 0, right? And we need that same constant change in y over change in x. So 5 was 90, 4 was 67, 3 was 44, 2 was 21, but what's the difference here? It's 23. So I got to go, if I'm going this direction, if I'm going down, I add 23. So if I'm going backwards, I'm going to subtract 23. So 2 was 21. Let's make sure we have these. Okay, I'm going to take away 23 from 21. And what do I get? I get negative 2. And then if I take away 23 more, I get negative 25. So do you see right there? If our table went to 0, it would be 0, negative 25, and then I would have my y-intercept. So if your table does not include the y-intercept, you either have to find that difference however you can, or you can just extend your table so it does actually include 0. So 23x minus 25 is what we're looking for here. Let me put that in, 23x minus 25. So that was the trickiest one we've had so far. All right, so again, let's see. Can we just add? That would be plus 55. That is definitely not just plus 55, is it? So it's not just adding. Is it multiplying? Well, let's see. I don't think so. 1 times 56 is 56, but 2 times 56 is not 68. So since we're not just adding and we're not just multiplying, it's going to be a combination of adding and multiplying, or better said, multiplying and adding, because of order of operations. So again, slope is my change in y over my change in x. So let's find that slope. Let's find that change in y over change in x. All right, so here we go. 56 to 68, that's plus 13, right? So it's plus, hold on, it's not plus 13. How about plus 12? Is that better? Plus 12, plus 12, plus 12. This one is plus 1, plus 1, plus 1. So our slope is 12. So that tells me I'm multiplying by 12, right? So 12 times 1 is 12, but I need to get over to 56, right? 12 times 2 is 68, but I need to get all the way over to 12 times 2 is 24, but I need to get all the way over to 68, right? 12 times 3 is 36, but I need to get all the way over to 80, right? So what am I going to do? In this case, obviously, I'm adding something. That's what it tells us. We're going to add something. So one way to do it is simply subtract. Well, 56 minus 12 is what? 44. So that tells me that I need to add 44. Does it work? 36 plus 44 is 80. Yep. Okay, so that's one way to do it. Find the difference between those two numbers. All right, another way we can extend our table. Now, I'm just going to go, because it's just right here, right? 4, 3, 2, 1, 0. It was going up by 12, so then I go down by 12. And do you see how that gets me to 44 right there? 44, Mr. Reeves, not 14. All right, 44. There is my y-intercept, because remember, that is your y-intercept, and remember, it's always 0b, right? This is our slope, which is our change in y over change in x. So what does this say? How do I get y from x? I multiply by 12, and I add 44. Okay, so technically you don't have to know slope and y-intercept to do these, but that's supposed to help you. All right. Okay, let's skip over to the challenge zone and see if they've got anything that's a little bit more challenging. All right, I've been looking at this before, and I got to be honest with you, other than you having to put the entire equation in, it's a lot more of the same. All right, so let's see first. Can I just add something? Take a look. Can I just add something? I sure can. If I want to know what y is, I can simply take x and add what, boys and girls? What am I adding? I'm adding 21, right? So this is one of those most simple cases where we're just adding. What about this case? Are we subtracting the same thing every time? Well, if I do 33 minus what will I get 4? 33 minus 29 is 43 minus 29 going to be 14. 53 minus 29 going to be 54. All right. Sure looks like I could just subtract 29 every time, right? Y equals x minus 29. Do we get the same answer when we do that? We sure do. All right, that one's plus 2. That one is definitely not plus 2, right? So adding does not give us what we want this time. What about multiplying? Well, no. Let's see. 6, no. So that means this is one of those more challenging ones, right? Y equals mx plus b. We're going to have to do a combination of the two. Remember, I know I keep saying it. I'm going to say it over and over again. Y equals mx plus b, where m is the slope and b is the y-intercept, and slope is change in y over change in x. So that's going to tell us what we're multiplying by here. So let's go ahead and find that slope. All right. So from 8 all the way down to negative 17. Well, we're going down from 8 to 0 would be 8, and then another 17, that's minus 25. And if you take a look, all three of those are minus 25, and these are going up by what? 5 plus 5 plus 5 plus 5. So what do we get? Our slope, our change in y over our change in x is negative 25 over 5, or negative 5. So that tells us we're multiplying by negative 5. So I can go negative 5 times 6 is negative 30. But what do I need? I need 8, right? Negative 5 times 11 is negative 55. But what is my answer supposed to be? It's supposed to be negative 17. So again, the question is, in this case, we're going to be adding something, right? Because we're going from negative 30 to 8. Well, how far is it from negative 30 to 8? Well, from negative 30 to 8, if I do negative 30 minus 8 and I take the absolute value, that's a difference of 38, right? So if I add 38, it works, doesn't it, right? Negative 55 plus 38 is 17. So I can see that my equation, that's my y-intercept. So B is positive 38. So I know my B and I know my M. So my equation is going to be y equals negative 5x plus 38, right? Now this would be a little tricky if we tried to do that table method. I'm going to go over here. If we went 21 and we went 16 and we went 11 and we went 6, well, the difference between each of these was 5, right? So if I did it again, I would be at 1 and then I would be at negative 4. And you see how it skips over 0? So the table method on this one would be a little bit more tricky. We could figure it out. We could do it. But in this case, I think just finding the difference between those numbers is the way to go. There's also an algebraic way that's really not so bad. The problem is we haven't done any equation solving yet, which makes this process a little bit more difficult, right? Because if I did 1, 8, this would be 8 minus 25 for our next one, right? So that would be negative 17. And then if I did minus 25, what's that? Negative 42. And you'll notice our 38, whoops, excuse me, I'm supposed to be going up by 25. Sorry, guys, up by 25. 8 plus 25 would be 33, and 33 plus 25 would be 58. And you'll notice that the answer we wanted, our answer of 38 at 0 is in between those two. All right, so we would have to break it up. We would say if it's going up by 25 every 5, right, then the change is 1. 5 is every 1. So we would break this table up. Instead of going by 5s, we would go by 1s, right? And you could see from 33 plus 5 is 38. So it's really not so bad. Just requires us to do a little bit more tricky things going on here. Y equals negative 5x, and it was what? Plus 38, right? Was that what it was? I hope that was what it was. Alrighty. Okay, I'm going to go ahead and stop there. Hopefully I did enough examples. I did a lot of examples. Just remember, when you are writing an equation comparing y and x, you are simply asking yourself, what do I have to do to x to get to y? Am I just adding or subtracting? Am I multiplying? Or am I doing a combination of multiplying and adding and subtracting? All right, until next time, see ya.